Good day everyone. Welcome to M115 Abstract Algebra. In this video, I will show you my unique geometric model named Petal Player. I'm Danica Andres from Beside Math 3A. My geometric model is named Petal Player, and this is the figure. This geometric figure features 8 equally spaced pointed segments radiating from a central circle, forming a flower-like design with rotational symmetry. It visually represents several mathematical concepts, including equal partitioning of a circle, each segment occupying 45 degrees, radial symmetry, and angle consistency. These are the elements in front and back. In front part, we have elements G, R, O, W, T, I, M, and E. And in back part, we have 1, 2, 3, 4, 5, 6, 7, and 8. Now, let's explore the different moves that will be used. First, the element G, we have do nothing. Next, for the element R, rotate 45 degrees counterclockwise. For element O, rotate 90 degrees counterclockwise. For element W, rotate 135 degrees counterclockwise. For element T, rotate 180 degrees counterclockwise. For element I, rotate 225 degrees counterclockwise. For element M, rotate 270 degrees counterclockwise. And lastly, for element E, rotate 315 degrees counterclockwise. For the element of the back, we will use the following line symmetry. First is the vertical axis. Next, we have horizontal axis. Third is the right diagonal, then left diagonal. Next is between right diagonal and vertical axis. Then between right diagonal and horizontal axis. Next is between left diagonal and vertical axis. Then between left diagonal and horizontal axis. For element 1, we have flip vertically. This is the vertical axis. Next is the element 2. We have flip between the left diagonal and vertical axis. Then is the element 3. We have flip about left diagonal. Next is the element 4. We have flip between left diagonal and horizontal axis. Next is the element 5. We have flip horizontally. Next is the element 6. We have flip between right diagonal and horizontal axis. Next is the element 7. We have flip about right diagonal. Next is the element 8. We have flip between vertical and right diagonal. Now these are the 16 symmetries we have. For element G, we have do nothing. For element R, we have rotate 45 degrees counterclockwise. For element O, we have rotate 90 degrees counterclockwise. For element W, we have rotate 135 degrees counterclockwise. For element T, we have rotate 180 degrees counterclockwise. For element I, we have rotate 225 degrees counterclockwise. For element M, we have rotate 270 degrees counterclockwise. And for element A, we have rotate 315 degrees counterclockwise. counterclockwise. For the line we have, for element 1, we have flip vertically. For element 2, we have flip between the left diagonal and vertical axis. For element 3, we have flip about left diagonal. For element 4, we have flip between left diagonal and horizontal axis. For element 5, we have flip horizontally. For element 6, we have flip between right diagonal and horizontal axis. For element 7, we have flip about right diagonal. For element 8, we have flip between vertical and right diagonal. Now, if we have G star R, the first move is G, which is do nothing. Then the second move, we have to rotate 45 degrees counterclockwise, and we will get R. So G star R is equal to R. Next is if we have R star O, for the first move, we have rotate 45 degrees counterclockwise, and for the second move, we need to rotate 90 degrees counterclockwise, and we will get element W. So R star O is equal to W. If we have O star T, for the first move, we will have rotate 90 degrees counterclockwise, and for the second move, we need to rotate 180 degrees counterclockwise, and we will get element M. So O star T is equal to M. Next is if we have 1 star R, for the first move, we have flip vertically, and for the second move, we need to rotate 45 degrees counterclockwise, and we will get element 2. So 1 star R is equal to 2. After following the moves, these are the possible combinations. We conclude that the table with a binary operation star. Task number 1, showing that it forms a group structure. Group. A group star is a set G closed under the binary operation star such that the following conditions are satisfied. For G1, for all A, B, C element G, we have quantity A star B star C is equal to A star quantity B star C. This is associativity of star. For G2, there is an element E in G such that for all E element G, E star X is equal to X star E is equal to X. This is the existence of the identity element E for star. And for G3, corresponding to each element G, there is an element A inverse in G, such that A star A inverse is equal to A inverse star A is equal to E. This is the existence of inverse element for all elements of G. A, it is closed under binary operation star because, as you can see, the resulting elements are all in the set. Next, G1, the associativity of star. To check if the group is associative, let's rotate the group table with 180 degrees. After rotating 180 degrees, let's interchange some rows and columns. First, let's interchange the column E and R. Next, let's interchange the column M and O. Next, let's interchange the column W and I. Next, let's interchange the column 1 and 7. Next, let's interchange column 6 and 2. And lastly, let's interchange column 5 and 3. Now, after interchanging some columns, we get the same structure with the original growth table. Therefore, the table with the binary operation store is associative. Now, let's move with the G2, existence of identity element E. In finding the identity element, let's look for a row that matches the elements in the outer top row. Then we have this row. And look for the upper column and matches the element in the outer left column. Then we have this column. Then the intersection of the column and row is the identity element. So in this, we have the intersection, which is the identity element, which is G. Therefore, the identity element E is G. For G3, existence of inverse element for all, where the identity E is G. First is G inverse is equal to G. Next is R inverse is equal to E. Next is O inverse is equal to M. Next is W inverse is equal to I. Next is T inverse is equal to T. Next is I inverse is equal to W. Next is M inverse is equal to O. Next is E inverse is equal to R. Next is 1 inverse is equal to 1. Next is 2 inverse is equal to 2. Next is 3 inverse is equal to 3. Next is 4 inverse is equal to 4. Next is 5 inverse is equal to 5. Next is 6 inverse is equal to 6. Next is 7 inverse is equal to 7. And lastly is 8 inverse is equal to 8. Therefore, it is a group because it satisfies all the conditions. We have it is A closed under binary operation star. For G1, it is associative. For G2, there is an identity element G, which is also found in the set. And for G3, there is an inverse element for each element.